Okay, here we are with another example, number 4. All right, how do you handle something like this? Well, sometimes you have to combine a few ideas. This one, we can see this cosine, it's never going to be, it's being squared, so it's positive, and it will never be bigger than 1. So we could say right out of the gate here that we have this. So we have a series that's less than or equal to a known to be convergent series. This is a P series with P equal to 2. So by direct comparison, it's convergent. Okay, it's less than or equal to a convergent series. So that was not too bad. Now we're going to jump down to part C there. I just want to show you how to get this one started. I don't want to make this video too long, but again, it's we've got this n over e to the n squared. So you probably suspect that it's going to converge because that denominator is really pretty big. It's going to converge. Did I say diverge? Well, we suspect it'll converge. And a couple different things we could try. One might be the integral test on this one. I don't, to be able to compare it to another series, you'd have to work with this e to the n squared series, which hasn't been an established 1 over e to the n squared. It's not really established at this point as being convergent, but so you might want to try the integral test for that. So check the conditions. Number 1, it is positive. Okay, function is positive. It is continuous. And it is decreasing. That might take a little bit of work, but you can show it without too much trouble with a derivative. For example, if f of x were equal to x e to the negative x squared, then f prime would be e to the negative x squared, and then minus 2x squared e to the negative x squared. And you can see that this thing, this will be equal to e to the negative x squared on the 1 minus 2 x squared. And you can see, of course, e to the negative x squared will never be negative. This is your only possibility of going negative, and that'll happen if 1 is less than 2x squared. So you would be solving this inequality to determine that. And that's going to happen for x greater than 1 over root 2, square root of 1 over root 2, x less than negative 1 over root 2. So it does happen for sure past x equals 1. And therefore, for sure, for n equals 1. So conditions are right. Next would just be to find that integral. X e to the negative, oh, don't want that. X e to the negative x squared. Okay, and that's that's an e to the u du problem. We end up with a minus 1/2. It's going to be negative 2x. So we end up with this. And we're going from 1 to infinity. And I'm leaving out some of the technically accurate writing here with my limit notation. So you've got this thing heading to infinity, right? So being kind of sloppy here with this, you'll have e to the negative infinity plus a half e to the negative 1. And you can see this is going to head to 0, 1 over e to the infinity. So this is just a finite number, and it is convergent. And that is by the integral test. So sometimes that's the test we need. All right, sorry this video was so long. Apologize for the sloppiness also. This tool's hard to work with.